Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're going to complete the main trigonometrical ratios of the acute angles. The main trigonometrical ratios of the angles measuring 30° and 60°. In the opposite figure, ABC is a right-angled triangle at B, in which measure of angle A equals 60° and measure of angle C equals 30°. So this triangle is called 30 and 60 triangle. And here we got a theorem from grade 8. Since AB, the side AB opposite to the angle whose measure 30°, that means the length of this side equal half of the length of the hypotenuse AC. Again, if we have a side in the right angle triangle, if we have a side opposite to the angle whose measure 30°, this side equals half the length of the hypotenuse AC. Or we can say that the ratio between the side AB and the hypotenuse AC is 1 to 2. Now BC is a missing side. We can find it by using the Pythagoras theorem. If we break this ratio, if we multiply each term of the ratio by a variable and then find BC by using the Pythagoras theorem, it's going to be √3. Now we can find any trigonometrical ratios according to the angle 30° and the angle whose measure 60°. Suppose we need to find the first trigonometrical function sine of the angle 30. As we studied in the previous lesson, the sine of any angle equals the ratio between the opposite side of this angle and the hypotenuse. And the opposite side of the angle 30 is AB. And the hypotenuse is AC, so it's going to be AB over AC. AB equals 1. The ratio of AB and AC is 1 to 2, so it's going to be 1 over 2. And the second trigonometrical function is cosine. We need to find cosine 30. As we studied before, that cosine of any angle equals the ratio between the adjacent side of this angle and the hypotenuse. And the adjacent side of the angle 30° is √3 and the hypotenuse 2, so it's going to be the ratio √3 over 2. And the third trigonometrical function is tangent of the angle 30. We know that tangent of any angle equals the ratio between the opposite side of this angle and the adjacent side of this angle. So it's going to be 1 over √3. The opposite side of the angle 30 is 1 and the adjacent is √3. So it's going to be 1 over √3. Also, we can find the trigonometrical ratios according to the angle whose measure 60°. Sine of the angle 60 equals the ratio between the opposite side of the angle 60 and the hypotenuse. And the opposite side of the angle 60 is BC, √3, and the hypotenuse is 2, so it's going to be √3 over 2. And the second trigonometrical function, cosine. We need to find cosine 60. Cosine of any angle equals the ratio between the adjacent side of this angle and the hypotenuse. And the adjacent of 60 is AB and the hypotenuse AC, so it's going to be 1 over 2. And the third trigonometrical function, tan. We need to find tangent of the angle 60. It's going to be the ratio between the opposite side of the angle 60 and the adjacent. At the opposite side of the angle 60 is √3 and the adjacent is 1, so it's going to be √3 over 1, or we can ignore 1, it's going to be √3. The main trigonometrical ratios of the angle measuring 45. In the opposite figure, ABC is an isosceles triangle where AC equals BC. And measure of angle C equals 90°. So this is also right-angled triangle at C. That means the ratio between the side AC and the side BC is 1 to 1. Now we can break this ratio if we multiply each term of the ratio by a variable, and then we can find the missing side or the missing hypotenuse AB by using the Pythagoras theorem, and it's going to be root 2. Also, we can find any trigonometrical ratio according to the angle 45. Angle A or angle B, each one of them equals 45 degrees. Sine 45. We know that sine of any angle equals the ratio between the opposite side of this angle and the hypotenuse. And the opposite side of the angle 45 is 1. 45, its opposite side is 1, and the hypotenuse is root 2, so it's going to be 1 over root 2. And cosine of the angle 45. We know that cosine of any angle equals the ratio between the adjacent of this angle and the hypotenuse, and the adjacent of the angle B45 is 1. Also, the adjacent of the angle A45 is 1. And the hypotenuse is root 2, so it's going to be 1 over root 2. From here, we can deduce that sine of the angle 45 is equivalent to cosine of the angle 45. If we need to find tangent of the angle 45, we know that tangent of any angle equals the ratio between the opposite side of this angle and the adjacent. And the opposite side of the angle 45 is 1, and the adjacent is also 1. So the final result is going to be 1. So the tangent of the angle 45 equals 1. Again, sine of the angle 45 is equivalent to cosine of the angle 45 equals 1 over root 2. Find the value of each of the following. Letter A, cosine 60 sine 30 plus sine 60 cosine 30. We know that cosine 60 equals half. And sine 30 also equals half, plus sine 60, sine of the angle 60 equals root 3 over 2, and cosine 30, cosine of the angle 30, root 3 over 2. Half times half equals 1 over 4, and root 3 over 2 times root 3 over 2 equals root 3 times root 3 equals 3, and 2 times 2 equals 4. Now we have two fractions having the same denominator. We can put the same denominator and add the two numerators. It's going to be 4 over 4. And 4 over 4 equals 1. Letter B, cosine 60 plus sine 30 minus tangent of the angle 45. We know that cosine 60 equals half, and plus sine 30, sine of the angle 30 also equals half, minus tangent of the angle 45, tan 45 equals 1. Half plus half equals 1, minus 1 equals 0. Prove that tangent tan square 60 equals tangent of the angle 45 plus twice tangent 30 tan 60. Since the left-hand side equals tan square 60, we know that tan 60 equals root 3. That means tan square 60 equals root 3 power 2. We can cancel the square root with the power 2. It's going to be 3. And this is the left-hand side. And since the right-hand side equals tan 45 plus 2, tan 30, tan 60, we know that tan 45 equals 1 plus 2 times tan 30 equals 1 over root 3 times tan 60 equals root 3. Now we can cancel root 3 with root 3, and then it's going to be 1 plus 2 equals 3. From here, we can deduce that the left-hand side equals 3 and the right-hand side equals 3. That means the left-hand side equals the right-hand side. Find the value of x if 1 over 8x equals cosine squared 30, tan squared 30, tan squared 45. 1 over 8x equals, we know that cosine 30 equals root 3 over 2. That means cosine squared 30 equals root 3 over 2 power 2 times tan squared 30. We know that tan 30 equals 1 over root 3. That means tan squared 30 equals 1 over root 3 square times tan squared 45. We know that tan 45 equals 1. That means tan squared 45 equals 1 power 2. Root 3 over 2 power 2. We can distribute the power over the numerator and the denominator. Root 3 power 2 equals 3 and 2 power 2 equals 4 times 1 power 2 equals 1 and root 3 power 2 equals 3 times 1 power 2. Now we can cancel root 3 with root 3, then the final result is going to be 1 over 4. That means 1 over 8x equals 1 over 4. We can multiply each side of the equation by 8. That means 8 can cancel this 8, so x is going to be 2, because quarter times 8 equals 2. Using the scientific calculator, find the value of each of the following, approximating the result or the result to the nearest 3 decimal places. Cosine 32, we can write in the calculator cosine 32 and it's going to be 0.848. Also, we can press sign in the calculator and write 41 degree and 52 minutes and press equal, and the result is going to be 0.667. Letter C, tan. We can press tan in the calculator and write 28 degree 43 minutes and 28 seconds and press equal, and then the result is going to be 0.548. Example, find the measure of the acute angle x in each of the following. Cosine x equals 0.6752. We need to find the measure of the acute angle x. What should I do? All you have to do is press shift in the calculator and then write 0.6752, and then the result is going to be x equals this value. We can press we can convert it by using the calculator into degree and minutes and seconds, and it's going to be 47 degree and 31 minutes and 49.14 seconds. Sine x equals 0.2579. We can press shift in the calculator and then write 0.2579. And then x is going to be this value. And then we can convert it into minutes and second and into degree and minutes and seconds, and it's going to be 14 degree and 56 minutes and 43.77 seconds. Tan x equals 0.9578. We can press shift in the calculator and then write 0.9578. And then the value of x is going to be this value. And then we can convert it into degree and minute and seconds. It's going to be 43 degree and 44 minutes and 54.69 seconds. ABC is a right-angled triangle at B. AB equals 8 centimeter and measure of angle C equals 52. We need to find the perimeter of the triangle ABC to the nearest centimeter. What should I do? We know that the relation between the side AB and the side BC and the angle C is tan, because tangent of the angle C or tangent of 52 equals the ratio between AB and BC. And we know that AB equals 8 and BC is missing. We need to find the length of the side BC. We can replace tan 52 by BC, and it's going to be BC equals 8 over tangent of 52. That means BC is going to be approximately equals 6.25 centimeter. And we know that sine of the angle 52 equals the ratio between the opposite side AB and the missing hypotenuse AC. We know that AB equals 8. We can substitute by AB equals 8. And then we can replace sine 52 by AC. So AC is going to be 8 over sine 52, and it's going to be approximately equals 10.15 centimeter. Now we have all the side lengths of this triangle. We know that the perimeter of any triangle equals the sum of all side lengths in this triangle. So we need to add these sides in this triangle. 8 plus 6.25 plus 10.15 equals 24.15 centimeter. ABCD is a rectangle where AB equals 5 centimeter and AC equals 13 centimeter. And we need to find measure of angle BCA and the area of the rectangle ABC. Since sine of the angle BCA equals the ratio between the opposite side AB and the hypotenuse AC, because measure of angle B is 90 degree. This is a right angle triangle ABC, because this is a rectangle and each angle in this rectangle equals 90 degree. So the measure of angle B equals 90 degree. That means the triangle ABC is a right angle triangle. That means since sine of the angle BCA equals the ratio between AB and ABC and AC, sorry, this is must be AC, the hypotenuse AC, not BC. That means sine of BCA equals 5 over 13, because the opposite side of the angle BCA is 5 and the hypotenuse is 13 centimeter. Now we can find the angle BCA. If we press shift sign in the calculator and then write 5 over 13, and it's going to be this value. And then we can convert this value by using the calculator. We can convert it into degree and minute and seconds. And it's going to be 22 degree, 37 minutes, and 11.51 seconds. Now we can find the missing side BC by using the Pythagoras theorem. Since measure of angle B equals 90 degree, that means BC equals square root 13 square minus 5 square. And it's going to be 12 centimeter. Now we have the length of the rectangle is 12 centimeter and the width of the rectangle is 5 centimeter. That means the area of the rectangle equals length times width equals 12 times 5 equals 60 centimeter square. And this is the area of the rectangle. ABCD is trapezium, where AD parallel to BC and AB equals 3 centimeter, and measure of angle B equals 90 degree, and BC equals 10 centimeter, and AD equals 6 centimeter. And we need to prove that cosine of the angle DCB minus tangent of the angle ACB equals half. At the first, we need to make a construction. We need to draw a height DE perpendicular to the base BC. Now we got a rectangle. This is a rectangle. ABED is rectangle. That means we can deduce that DE equals the side AB equals 3 centimeter, and BE equals AD equals 6 centimeter, because we know that each two opposite sides in the rectangle equal in length. That means EC equals the difference between 10 and 6. If we subtract 6 from 10, it's going to be 4 centimeter. That means CE equals 4 centimeter. Now in the right angle triangle DEC, DC is the missing side in this triangle, or the missing hypotenuse. We can find this hypotenuse by using the Pythagoras theorem. It's going to be square root 4 square plus 3 square equals 5 centimeter. And now we can easily find cosine of the angle DCB. We know that cosine of any angle equals the ratio between the adjacent side of the angle and the hypotenuse. And the adjacent side of the angle DCE is 4 centimeter, and the hypotenuse is 5 centimeter. So it's going to be 4 over 5. And to find tangent of the angle ACB, we need to join A with C. We need to make a construction AC. So in the right angle triangle ABC, tangent of the angle ACB equals the ratio between the opposite side AB and the adjacent side BC. And the opposite side is 3 centimeter, and the adjacent BC is 10 centimeter. So it's going to be 3 over 10. Now we can find the value of the left-hand side. Cosine the angle DCB minus tangent of the angle ACB. It's going to be 4 over 5 minus 3 over 10. If we subtract 3 over 10 from 4 over 5, the result is going to be 1 over 2. And this is equivalent to the right-hand side. Thanks, guys. The time is over. I hope you study hard. Wassalamu alaikum wa rahmatullahi wa barakatuh.